When x is increasing by 1 in a linear table, it's really easy to find the rate of change. The rate of change is just how much y is increasing or decreasing by. However, when x isn't just increasing by 1, you have to do some work to find the rate of change. The rate of change is found using this formula, which is read delta y over delta x. This little triangle is a delta. So delta y over delta x. Delta means change in. So I'm going to find the change in y and divide it by the change in x. This will give me my rate of change. Let's look at this first table. Now the start value is still easy to find in this first table. The start value is the value of y when x is 0. The start value is just 7. To find the rate of change, I have to use this formula because x isn't just going up by 1. I need to find the change in y and divide it by the change in x. The change in x for each row of this table is just 3. To go from 0 to 3, I'm adding 3. To go from 3 to 6, I'm adding 3. To go from 6 to 9, I'm adding 3. That tells me that delta x is 3. Delta y is what am I adding to 7 to get 13? I am adding 6. What am I adding to 13 to get 19? I'm adding 6. What am I adding to 19 to get 25? I'm adding 6. If you can't just look at the table and see what you're adding or subtracting, you can work backwards, taking one row and subtracting the previous value in order to find that change. So 19 minus 13 is 6. 13 minus 7 is 6. So sometimes you'll just be able to look at it and see that you're adding 6. Sometimes you'll need to subtract in order to identify that change. All right, so the rate of change, delta y divided by delta x. For each row, that delta y is 6, and the delta x is 3. That means my rate of change is 6 divided by 3, which is 2. Please notice that it does not have to be the case that delta y is always the same. It doesn't have to be the case that delta x is always the same. What needs to be the case is that when you divide delta y by delta x, that is a constant. The rate of change is constant. So it would have been okay if suddenly x went up by 6, as long as y went up by 12. Or if x went up by 30, as long as y went up by 60. What needs to remain constant is the change in y divided by the change in x. All right, my equation, y equals mx plus b, y equals 2x plus 7, which I could also write as y equals 7 plus 2x. Next example. This example is a little harder because the start value is not given in the table. To find the start value, I'm going to need to first find the rate of change and then to work backwards to find the start value. In this table, x is increasing by 3. Y is increasing by 9, plus 9. Again, if you can't just see, oh, I'm adding 9 to 21 to get 30, I can subtract 30 minus 21, 9. 21 minus 12, 9. My rate of change is the change in y, 9, divided by the change in x, 3. My rate of change is 3. Now I have to work backwards to find my start value. My start value is not given in my table. I need to find the value of y when x is 0. That means instead of adding 3, I'm going to need to repeatedly subtract 3 until I find the value of y when x is 0. By the way, a really common mistake here would be to subtract 9. That's not what I'm going to subtract because I'm just having x go back by 1. So when I'm trying to find the value of y when x is 1, I just subtract 3 from 12. So I'm working backwards. Instead of going forward, adding 3, adding 3, adding 3, when I'm working backwards, I subtract that rate of change. I need to go backwards one more time to find the value of y when x is 0. So subtracting 3 one more time, this tells me my start value. My value of y when x is 0 is just 6. Okay, I found my rate of change, delta y over delta x. I used my rate of change 3 to work backwards to find the start value, and now I can write my equation. My equation is just y equals mx plus b, y equals 3 times x plus 6, which I could also write as y equals 6 plus 3x.